Hey guys, welcome. Yeah, so this will be the first of a number of videos on the Euler Phi function. And as with any of my video series on a particular topic, these videos are meant to be watched in order, of course, starting with this introduction. So, what is Euler's Phi function? Euler's Phi function phi of n, what it does is it counts the number of positive integers x that are less or equal to n and relatively prime to n. What? Okay, so this is all it does, phi of n. It takes n, right? It writes down all of the positive integers that are less or equal to n, right? And it looks at that list and counts how many of them do not share a common factor with n. And of course, having a common factor of 1 doesn't count, right? So it counts how many integers less or equal to n do not have a common factor with n other than that common factor being 1. Yeah? Okay, cool. So, let's see it in action. Phi of 2 is 1 because, well, only 1 and 2 are less or equal to 2, right? And looking at 1 and 2, 2 obviously has a common factor with 2. It's 2, not just 1, right? But 1 doesn't share a common factor with 2 other than 1, and therefore 5, 2 is 1 because only one of the two numbers that are less or equal to 2 doesn't have a common factor with 2. Okay, alright. 2 is kind of hard to deal with, so let's look at 3. And bigger numbers will help. So 5, 3 is 2 because the list here is 1, 2, and 3. Those are the positive integers less or equal to 3. And in that list, 1, 2, and 3, only 1 and 2 do not share a common factor with 3. And therefore, there are two numbers, two positive integers specifically, less or equal to 3 that are relatively prime to 3. Relatively prime meaning do not have a common factor with 3 other than 1 being the common factor. Yeah? Okay. 5, 4 is 2 because the list here is 1, 2, 3, and 4. And only 1 and 3 do not share a common factor with 4. Yeah? Okay. And 5, 5 is 4 because the list this time is 1, 2, 3, 4, 5. And 1, 2, 3, and 4 do not share a common factor with 5. So there's 4 of them. Yeah? Okay. And then 5, 6 is 2 because only 1 and 5 do not share a common factor with 6 when looking at the list, which is 1 through 6 this time, right? Okay. And 5, 7 is 6 because the list this time is 1 through 7, and 1 through 6 do not share a common factor with 7, right? Okay, are you seeing a pattern in particular in what's highlighted in yellow? Hopefully. And at 5, 8 is 4 because the list is 1 through 8, right? But only 1 and then 3 and then 5 and 7, that's 4 of them, do not have a common factor with 8. Yeah? Okay, I think you're getting it. This is the pattern you should have seen, which is when n is a prime number p, then 5p is p minus 1. For example, 2 is prime and 5, 2 is 2 minus 1. 3 is prime, 5, 3 is 3 minus 1. 5 is prime, 5, 5 is 5 minus 1. You get it. This will be important for you to keep in mind for future videos, knowing that 5p is p minus 1. Also, before we conclude, 5, 1 is 1, because the list this time is just 1, but 1 is relatively prime to 1. That is the greatest common divisor of 1 and 1 is 1. And the formal definition of relatively prime is using the GCD, but I avoided using it just in case it was confusing to some students who are just trying to figure out what the Euler Phi function is and don't have the technology, which is the earlier preparation. Anyway, I hope you enjoyed this video and lots more to come. Yeah, keep watching. Take care.